Assalamualaikum warahmatullahi wabarakatuh. Good morning. Today I will presentation English Maritime with topic analyzing and presenting the marine oil lubricating system from the research publication. This time I will present article from the Presentaion Engineering with title The Influence of Oil Pressure in the Engine Lubrication System on Friction Losses. Background of the study. The development of internal combustion engine have been focused in the last 3 decades on the reduction the negative impact on natural environment. To a large extent, it is associated with the reduction in toxic exhaust emission into the atmosphere, but also with the reduction of carbon dioxide emission, which although in the not toxic gas, but it is considered as harmful because it intensifies the occurrence of the greenhouse effect. The reduction of carbon dioxide emission can only be achieved by reducing the consumption of hydrocarbon fuels. Aim or objectives. The purpose of the internal combustion engine lubricating system is provide optimal condition for the oil film information in all friction couples such as a piston cylinder, piston ring cylinder, main bearing, and each. The oil film is designed to minimize the wear of the elements while ensuring the smallest possible friction losses. Lack of continuity of the oil film and thus boundary or mixed friction condition obviously have a negative effect on the friction loss. However, the continuous oil film, depending on the condition of its formation, may be characterized by different value of friction losses. One of factors that may affect the condition of formation of the oil film is the value of oil pressure in the lubrication system. Supporting theories. Developing the engine construction, design engineers have focused during last decade on oil pump losses. The external gear oil pump is equipped with regulator valve which regulates only the maximum oil pressure in the system. When the engine speed increases, the delivered rate of pump also increases because the oil consumers in the engine cannot process the excess oil being delivered. So the oil pressure in the system increases, and while the oil pressure exceeds a nominal value, the pressure limiting take place inside the pump. A mechanical valve opened for this purpose. However, since the pump is still operated at its maximum delivery rate, a portion of the input energy is converted to heat, which means this part of energy is lost. The simple oil pressure regulation does not meet the engine requirement, especially for the range of low and medium engine speed and engine load. This situation is presented in the figure number 2. I will explain what is drawing number 2. The red line represents the required engine oil pressure, while the yellow and blue lines represent the actual oil pressure delivered by oil pump of two different engines. It is clear that the oil pressure is too high for the whole engine speed operating range. The situation could not be avoided for simple regulation with the spring control valve. The free method of regulation were developed, then their goal was to match the required oil pressure with the pressure delivered by the pump by means of oil pump delivered rate regulation instead of pressure release regulation. The regulated oil pressure is represented by green line in the figure number 2. This allowed to reduce the oil pump drive power and decrease the engine fuel consumption. Example of regulator fan pump from 3.0 TDI engine is presented in figure. The lower oil pump deliver rate means that less oil volume get to all the friction pairs of the engine, especially to the journal bearing of the crankshaft and camshaft. Authors decided to investigate how will engine kinetic pairs operate for low oil supply in mean of friction loss. It will be the most unfavorable situation if the friction loss are higher, which means that the friction change in the character from fluid to mix. Instruments. The test stand. The test stand consists of the modified internal combustion engine which is driven by electric motor. It is a two-cylinder inline water-cooled spark ignition engine. The driver is transmitted by shaft, which is equipped with the HMB T5 tensiometer torquemeters, enable accurate measurement of the torque with high sample rate. The engine camshaft is immobilized, leaving the intake and exhaust valve in a closed position. Furthermore, the coolant pump and oil pump, which are real engines, are driven from the crankshaft, are disengaged and replaced with an external pump, both driven by electric motors. This allows to exclude the valve train, oil pump, and coolant pump power from the measuring torque. The seams and view of the test is shown in the figure number 4 and 5. Conclusion or result. The result indicates that the friction loss of the combustion engine cranks mechanism do not directly depend on the oil pressure. For said engine speed, the driving torque was almost constant for all oil pressure, and the difference were in the range measuring error. It is a clear evidence that for the test condition in all measuring point, friction was a fluid friction. This means there was no danger of additional wear in kinetic pairs element due to the low oil pressure in the engine lubricating system and the direction of reduction oil pressure for low engine speed and low engine load seems to be correct. It should be noticed that there was no combustion process in the test bed engine, so the load of crank mechanism was low, and it cannot be clearly concluded that oil pressure should be as low as possible in the engine in which combustion process occur, and as a consequence engine produce power. Nowadays, to achieve high power output in flow on of the engine speed and thereover to improve fuel consumption, engine must produce high torque at low engine speed. This means that the load of the crank mechanism is very high, and the future investigation should concentrate on the influence of high engine load on the friction loss in low oil pressure conditions. It should be kept in mind that lubrication is not the only test of the engine oil. The cooling friction of engine oil becomes more significant and cannot be omitted in further investigation. That's all. Thank you very much for your attention.